Here is my melting furnace. I have taped up the top and I've put some aluminium foil. This is because I'm going to paint it with some black stove paint. We're going to do this outside and it's going to look better. There's my new video light. That's on 85%. And here we got some newspaper. Some coffee. Do I look like that guy who wears one of these hats?
Feeling brave, colors explode in a neon hue. The world's alive, but I'm breaking through.
$250 grams potassium bromide. We add this also. We want about 300 milliliters water. Yes, we have a boiling solution here, and we have bromine coming over. Very good. I wouldn't suggest doing this indoors without a fume hood. If this goes wrong, you're in trouble. Thiosulfate has done a good job. It looks like all the bromine has come over and the condenser is slowly cleaning out. We can switch this for something else. Might as well let this clean the condenser for me. Just got another flask here. Here is the bromine we collected. We can see 2 layers of bromine on the bottom. Now then, as the system cooled down, some of the thiosulfate was sucked into here, which is a good thing. We will clean the rest of the equipment with thiosulfate. But first we need to I will pour this down the condenser and into here. Our glassware has been neutralized. Put a little bit more thiosulfate in there, so I think it's all been used up. I guess it's just going to stay yellow. This bottle is called a sewage bottle. It has not 1 but 2 stoppers, which should prevent bromine from escaping. It won't be 100%, but it'll be quite a bit better than just 1 stopper. This is isocyanauric acid, a precursor and component of many bleaches and disinfectants. Because of its trifunctionality, isocyanauric or cyanuric acid is a precursor to cross-linking agents for polyurethane resins as well as polyisocyanurate thermoset plastics. Look at my vacuum pump oil, that is disgusting. That's very bad. Acetone is good for washing this. Ooh, yikes, what is going on? It does not go through that middle adapter very well. That's why it was going through the vacuum pump. But we have our white isocyanuric acid. Don't worry, I'm getting a new vacuum pump very soon. This is going to be thrown out. Acetone may not have been the best for washing it. Hey, it's cleaned up the yellow. Some chemistry going on. This could also be potassium chloride, as it may have been a saturated solution. Now we are going to try and make a copper salt. I'm taking about 24 grams as this is wet, so I'm recording this as 20 grams. We will heat it up. It appears to be dissolving. Isocyanauric acid is not very soluble, but it will dissolve in hot water. We want 38 grams of copper 2 sulfate pentahydrate. My prediction is that copper will bind in either 1 or 2 places, but not 3. So we are going to try 2 ratios, a 1-to-1 ratio and a 2 cyanuric acid to 1 copper ratio. I have the copper sulfate in 2 beakers, 65 milliliters in each. We have about 410 milliliters of the isocyanauric acid solution. I have put 140 into 1 beaker, and we have about 280 in this one. There are still a few crystals, but I'm going to proceed. I will now add the first copper solution. I will now do the same to the other solution. This is the 1-to-1 ratio, and this is the 2-to-1 ratio. I will now add some of the 2-to-1 solution to a beaker, 50 milliliters. We are now going to dropwise add sodium hydroxide until the pH is around 8. This is enough to deprotonate the isocyanuric acid, but not enough to precipitate copper hydroxide. First we'll test the pH. 3 or 4. I think we're getting our complex. I think we're close to our 8, pH 8. I'll wait for our precipitate to settle. We will now filter. Now we can do the same with the 2-to-1. 8. We can see a slight color difference. The one on the right is the 2-to-1, and the one on the left is the 1-to-1. For comparison, there is some copper hydroxide. Copper hydroxide is much darker. Upon cooling, the isocyanuric acid crystallized out, showing that the complexation only happens at the right pH.